Hi. Okay. Today I'm going to be using the paper that is called Precal C Quiz Matrix Basics. So if you could find that handout, if you have the hard copies, pause the video. It is in the packet that has all the linear programming that we've been practicing, the new determinant inverse packet where we've been doing the linear programming. If you don't have the packet because you weren't in school when we handed it out, then you will want to just go to Schoology, go to the text chapter 7 folder, and one of the handouts in there will be for the quiz matrix basics. If you can't find the sheet, no big deal. I'm going to write all the problems down and we're going to do them. So here we go. Problem number 1 says, solve in the method of your choice. Now, you're not here with me, so I don't know what your choice of method is. You could do it either with substitution or elimination, or actually with Cramer's rule. Now, since we haven't practiced Cramer's rule in a few days, I'm going to go ahead and do that. But again, the directions for this problem say solve in the manner of your choice. So if you'd rather substitute or eliminate, that's fine. But I'm going to go ahead and use Cramer's rule. So remember, Cramer's rule is the method where you start with the determinant of the coefficients. So 2, 1, 3, negative 2. So I'm starting with my x's. These are my x's. These are my y's. And I'm going to evaluate that determinant. And remember, to evaluate that determinant, we multiply here. So negative 4, 2 times negative 2. And then 3 times 1. And then we subtract those. So it's negative 4 minus 3. So the value of that determinant is negative 7. Now remember, with Cramer's rule, that number becomes the denominator for both x and y. So whatever x and y turn out to be, it's going to be something over negative 7 because the value of this determinant was negative 7. Now, to find our x numerator, it's another determinant. And remember, we cut these numbers out. We haven't used these numbers yet. We cut them out and we paste them right here on top of the x's. So we have a 5 and a 4 here. And then our 1 and negative 2 don't change because we simply cut this out and pasted it right here. And then similarly for y, we're going to cut out this 5 and 4, but we're going to paste it on top of the y's. So we have 2, 3, 1, negative 2. 2, 3, 5, 4. I'm cutting out the 5, 4 and pasting it right there on top of the y's. So the x's stay put, and then the 5, 4 goes right on top of the y's. So now I'm going to evaluate those two determinants. Same way I did this one. So I'm going to multiply here. They really don't have much room, so I'll multiply here and get negative 10. I'll multiply here and get 4, and then I'll subtract those. So negative 10 minus 4. Well, negative 10 minus 4 is negative 14 over negative 7. So my x-coordinate works out to be 2. Negative 14 over negative 7. And then y, I do the same thing. So I'm going to multiply 2 times 4, multiply 3 times 5, and subtract them. So 8 minus 15. That gives me negative 7 over negative 7. So y is 1. No matter how you did this problem, whether you did substitution, whether you did elimination, no matter how you did it, your answer should come out to be 2, 1. Okay? All right. So next, we have some determinants and we're supposed to be doing some operations with them. So, let's see what we're doing here. So the first thing we're going to do, I'm on my Matrix Basics sheet. I am going to add A and B. Now, in case some of you don't have the sheet, would be great if you could download that into Notability. But in case you don't, we're going to add these two matrices. On the paper, this is A and this is B, and we're going to add them together. So our rule for addition is, remember what it is? You can't add unless they're the same size. Well, what are the dimensions of this matrix? 2 by 2. 2 rows, 2 columns. What are the dimensions of this matrix? 2 by 2. 2 rows, 2 columns. Since they match, we can add. So what will the sum be? Well, remember, you add corresponding positions. So 1 and -1 would make 0. 2 and 0 makes 2. 3 and 5 makes 8. And 6 and 4 makes 10. There's the sum of those two matrices. The next problem says, take 2 times this matrix. This matrix happens to be called C on the paper, but that's kind of irrelevant. We're doing 2 times it. 2 times it. So, we want to take 2 times that matrix. That's real easy. We just multiply 2 times all those numbers. So, -2, 2, 4. And 6, 10, 8. There we are. There is 2 times the matrix. Okay. These are all review problems. If any of this is confusing you, go back and watch an earlier video. Now we're doing A plus C. So that's matrix A, and then this was C. So now we're going to add these two together. Okay, so our job now is to add these two matrices together. Well, one more time. What's the rule for addition? They have to be the same size. Are these two matrices the same size? Why, no. This one's 2 by 2, and this one is 2 by 3. It has 2 rows, but it has 3 columns. And that's fine, but you can't add these because they're not the same size. So you simply put an empty set symbol, or you write can't add, not the same size. However you want to indicate that this is not a doable problem. Okay. Next, we have all kinds of random review here. That's why I'm doing this sheet. It's got good stuff on it. A sub 2, 1. Now, this is matrix A right here. Okay, that's matrix A. And we are supposed to find the entry in matrix A that is in the second row, first column. Remember, Roman Catholic, row column. Roman Catholic, RC, row column. So second row, first column. So second row, first column, that number is a 3. That is the number in matrix A that is in row 2, column 1. Row 2, column 1. Okay, the next problem says, what are the dimensions of C? Now, this is matrix C. You already told me, what are the dimensions of matrix C? 2 rows and 3 columns. 2 rows, 3 columns. Rows go this way, columns go this way. All right, now we're going to do a multiplication problem. So now we're going to multiply A times B. So we're going to multiply matrix A, 1, 2, 3, 6, times matrix B, negative 1, 0, 5, 4. We're going to multiply these together. Now, before we do it, we need to make sure that we actually can multiply. So, the rule for multiplication is different. Find the dimensions. So we have 2 rows and 2 columns. We have 2 rows and 2 columns. Now, the rule for multiplication, remember, isn't that they have to match. The rule for multiplication is these two have to match. And they do. So our answer will be that big right there. If these two match, we can multiply. If we can multiply, then our answer is those dimensions. So I'm going to end up with a 2 by 2, which means it has 2 rows and 2 columns. Now, I think it's easiest to go ahead and label those positions. You don't have to do this, but this spot right here is the first row, first column, first row, second column, second row, first column, second row, second column. Remember, rows go sideways. So if you're up here, you are in the first row. If you're down here, you are in the second row. Columns go this way. So if you're here, you're in the first column. If you're here, you're in the second column. To find the number that goes in the first row, first column, we're going to take the numbers in the first row and multiply them by the numbers in the first column. This is row 1. This is column 1. That's the 1, 1 spot. So, to be organized, I'm going to write down my numbers in the row. So that's 1, 2. And then next to that, I'll put my numbers in the column. That's negative 1, 5. So I wrote down the 1 and the 2. And I wrote down the negative 1 and the 5 right next to those numbers. Now I'm going to multiply each pair and add them up. So negative 1 plus 10 is 9. Now I'm going to move over here, and I'm going to do exactly the same thing. Only I'm going to multiply row 1 by column 2. Row 1, column 2. Row 1, column 2. So I'm going to write down my row 1, which is 1 and 2, and now my column 2, which is 0 and 4. So 1 times 0, 2 times 4, add them up, that gives me 8. Now I'm ready to move down to the second row. So I'm going to use my second row. And to find this one, I'm going to use the first column. So I've got my 3 and my 6. My 3 and my 6, second row. And then my negative 1 and 5. That's my first column. So second row, first column. And so negative 3 and 30, 27. And then finally, second row, second column. So 3, 6 and 0, 4. So that's going to be 24. And there we go. We have multiplied those two matrices. Okay, the next one on the sheet, we're almost done with the sheet. Oh, no, the next one on the sheet says we're going to multiply C times A. So we're going to do another multiplication, only this time we're going to multiply matrix C times matrix A. Okay, so this is C times A. We're going to do this multiplication. Remember, before you jump in and start doing it, I want you to check those dimensions. Make sure that it's possible. So what are the dimensions of this guy? We have 2 rows, we have 2 across, we have 2 rows, and we have 3 down. So it's a 2 by 3. That's 2 across, that's 3 down. This one is 2 by 2. Uh-oh. Trouble. These don't match. What does that mean then? That means that we cannot multiply. So I wasted a bunch of time writing that problem down. You can't multiply because they do not have the same inside dimensions there. Remember, in order to multiply, you have to have these two match. All right, we got one more problem. It says, oh, it's a subtraction. So we're going to take A and we're going to subtract 2 B's. Okay, so the problem says A minus 2B, and I've just written down the matrices that are on the paper for A and B. Now, is this problem going to be possible? Remember, for addition and subtraction, the dimensions have to match. Do those dimensions match for those two matrices? They sure do. Aren't they both 2 by 2s? They are. So we are going to be able to do this subtraction. But before we subtract, we probably ought to deal with that scalar. That number 2 right there, we call that a scalar. Probably ought to deal with that. How do we deal with that? Do you remember? We distribute it, don't we? Now, this is a subtraction, so you have to be careful. If you're going to keep it a subtraction, then you are distributing the 2 because you kept the minus sign. If you want to change this to plus a negative, you can absolutely do that too. I'm not going to, but you can do that. I am choosing to keep it as a subtraction, so I'm going to multiply everything by 2. So this is negative 2, 0, 10, and 8. My minus sign is still right here. All I'm doing is distributing the 2. So I took 2 times everything. Now I'm going to subtract. So I'm going to take 1 minus negative 2. What is 1 minus negative 2? 3? If you can't keep track of that, write it down for Pete's sake. 1 minus negative 2. And then 2 minus 0. 3 minus 10. And 6 minus 8. So first I distributed the 2, and then I subtracted. And that's our answer right there, right there. That's the answer to the problem. Good work. And that's it for that sheet too. So we are finished with that. All right, so I'm going to stay in the same packet now, and I'm going to do a couple of more linear programming problems. I know we've done these for several days. You're probably getting kind of tired of them, but practice makes perfect, so we're going to do a couple of more. Okay, so last time in our linear programming worksheet, on our linear, it's called Linear Programming Worksheet. Linear Programming Worksheet. We did problem A, or problem 1 already. So on the back side of that is problem 2. And problem 2 talks about Mackenzie making necklaces and earrings. So we're going to go ahead and do this one. So we have necklaces, earrings, and total. Okay? So hopefully you have the sheet. If you don't, it's in Schoology. This is the linear programming sheet. And it's problem number 2 on the linear programming sheet. It's about Mackenzie making necklaces and earrings. So it says each week, Mackenzie can make 10 to 25 necklaces and 15 to 20 earrings if she earns profits of $3 on earrings and $5 on necklace, and she plans to sell at least 30 pieces of jewelry. How can she maximize profit? Okay, so we want to maximize our profit, so we know that. We know we want to find out how many earrings and necklaces she should make. So I'm going to let X be the number of necklaces and Y be the number of earrings. Those are going to be my variables. X is going to represent necklaces and Y is going to represent earrings. So X is the number of necklaces I make. Y is the number of pairs of earrings I sell. Don't worry about them being pairs. Just that's how many sets of earrings we're going to sell. All right, so what about numbers now? What do we know? We can make between 10 and 25 necklaces. This is what happened to us yesterday in our problem. We have been given very strict boundaries for X, for necklaces. X has to be between 10 and 25. And then that carried over a little bit. That's just a lot to write in that little space. But X has to be between 10 and 25. So I'm going to write it over here. We have a little more room. They're telling me in the problem that I have to make between 10 and 25 necklaces. And I have to make between 15 and 40 earrings. I'm not making this up. This is not confusing. It tells me right there in the first sentence of the problem that X has to be between 10 and 25 and Y has to be between 15 and 40. Now it also says that the value or the profit on an earring is $3 and on a necklace is $5. It also tells me that I have to sell at least 30 pieces of jewelry. Now, kids, what does at least 30 mean? Okay, so this is the total. 30 is going to be the total. But at least 30 means X and Y have to be greater than or equal to 30. At least 30 means you're making 30 or more. Now, if you want to add them in, you can. They're not necessary in this problem, but X and Y are both positive. That's always the case in all of our problems. But again, because of these intervals that you've already set up, we don't even need to write that down this time, but it certainly isn't wrong to do it. So if it helps you to write them down, go ahead and write them down. And then what's our profit statement? What is our expression for the profit? Well, every X is worth 5 and every Y is worth 3. So there is our profit statement. Now, we're going to graph this. So, as usual, you got a grid set up there that you are welcome to expand. If you don't like the size of it, you are welcome to expand the graph however you would like to. Looking at these numbers, there's no way I'm going to be able to get a 40 in there. So I'm going to change my scale. Maybe we should let each box be worth 5. So I'm going to use a scale of 5. So that every mark on my grid is 5. So 5, 10, 15, 20, like that. Okay? Feel free to use the same scale on yours or make up whatever scale you want to use. It's completely individual. All right, I'm going to grab my green marker now. And I'm going to do this guy in green. Okay, so remember how that works. Remember from yesterday. This is only an x equation. That inequality, right here, the green one, only has x's. So I'm only looking at my x-axis, and I'm going to count over to 10, so that's 2 marks, so there's 10. That's the point 10, 0. And then I'm going to get 25, so 5, 10, 15, 20, 25 is right there. So that's 25, 0. So there are my 2 points, 10 and 25, because that's what the x's are. And now remember, I'm going to make nice vertical lines straight up my grid from those. So it looks like this. And I'm going to shade in between them, because x is supposed to be in between 10 and 25. All right. Then I'm going to get my purple marker. And I'm going to do my y's. And I'm going to do it exactly the same way, only now I'm on my y-axis. So 5, 10, 15. Here's 15. Okay. And then 40. So let's see, 15, 20, 25, 30, 35, 40 is right here. So I've marked 15 and I've marked 40. And then I'm going to draw nice horizontal lines right across my grid as straight as I can. My lines, wow, are not very straight. Those are supposed to be nice straight lines. And I'm going to shade in between them. Now you can see already we have formed a box. This box right here is what we're looking at. But we're not done yet because we still have one more equation to put in. So I'm going to get my red marker and I'm going to graph that one. Now when you graph this one, note this one has x's and y's. This one was only x's, this one was only y's, this is both. So when it's both, remember, we cover up one letter. So if we cover up x, we're going to graph y is 30. So I covered up x, y is 30, so it's right here. Okay, so I covered up x, y is 30, right here. Now I'm going to cover up y, and x will also be 30. So here's where y is 30. Here's where x is 30. And now I'm going to just go ahead and draw a nice straight line. To connect those. Okay, now this is where you got to really pay attention to your problem, because we have to shade that red line, and this is a greater than, which means I'm going to shade above that line. I don't know that we've done that so far. We're going to shade above that line, so we're inside the box, but we're above the line. So we end up with a shape that looks like this. It's got a corner here and a corner here, a corner here, a corner here, a corner here. because this line cuts that box off. So we end up with this shape right here, these 5 points. Can you see them? Those big blobs there? All right, now we got to figure out what those points are. Now, some of them are incredibly easy. For example, this guy right here. Seriously, guys, come on now. You counted over 10 and up 40. This is the point 10, 40. Okay, right here, 10, 40. Now, what about this one? Right here. Well, that one's over 25 and up 40. So 25, 40 is that one. So far I've got these 2 points. Now, what about this guy? He's super simple too. You counted over 25 and up 15. So he's 25, 15. So far we've got these. Now, these are the easy ones. Okay? Now, I want you to look carefully at this point right here. He is on this line, which means that y is 15. Y is 15 right there, okay? Now, if y is 15, then what does x have to be? On that red line, if y is 15, then x also has to be 15. So we have the point 15, 15. So again, I'm looking at this point right here. It is on this purple line, which means y is 15. It is also on the red line, which means that x and y have to add up to 30. So if y is 15, then x is also 15. Now, I'm going to do something exactly the same for this one. This one is on this green line. So I know that x is 10. X is 10. Any point on this line, x is 10. But it's also on the red line. If x is 10 on the red line, then y must be 20. So we have found the 5 points that are the corners of our feasible region. Okay, now I'm going to write those up here, these points. Because now we have to do something with them. So we have the points 10, 40, and these can be in any order. I don't know what order you have them written down. It doesn't matter. They can be in any order. All right, here they are. Those are the 5 points of our feasible region. Now, what do we do now? We have to figure out which one of those is the best answer. And how do we figure that out? By plugging each of these points into our profit. So for this one, for example, you're going to plug in 10 for x and 40 for y. So put 10 in here and 40 in here and figure it out. And do that for each point. Well, I go grab my calculator. Okay, have you got them figured out yet? So I got $270 for this one, and that's dollars. And $245 for this one. 110 for this one. 170. And 120. Now, I hope I did that right. I wish I were with you guys because you always do such a good job of checking me. So we plug everything in, and then what are we looking for? We're trying to maximize our profit, right? And if we're trying to maximize our profit, then we need to find the biggest profit, and I guess that's right here. So she should make 10 was X necklaces. I erased it. I think that was necklaces. 10 necklaces and 40 earrings for a profit of $270. All right, hopefully those are getting a little bit easier for you. Let's try one more. So I'm just going to go to the very next problem, which is problem 3. Remember, if at any point I'm going too fast or I say something you didn't quite catch, you just stop, back up, and do it again. Okay, here we go. We're ready for problem number 3. On the linear programming worksheet. So this time we are mowing and pruning. And my graphs are getting worse and worse as we go. So we're mowing, pruning, total. And we have hours, number, and income. And then we want to max or minimize something. And we got our constraints over here. All right. So here we go. Let's read the problem. Now let's see how much of this chart you can fill in without my help. That would be awesome. Let's see how much you can do. Let's see. A landscaping company has crews who mow and prune. The company schedules 1 hour for mowing jobs and 3 hours for pruning jobs. Stop right there, guys. 1 hour for mowing and 3 hours for pruning. It says right there in the problem, 1 hour for mowing, 3 hours for pruning. Each crew is scheduled for no more than 2 pruning jobs per day. Okay, we're going to have to come back to that. Each crew schedule is set up for a maximum of 9 hours per day. So the total is 9 hours per day. On average, the charge for mowing lawns is $40. So I get $40 when I mow, and I get $120 when I prune. Find a combination of mowing lawns and pruning shrubs that will maximize the income. So I want to maximize the income, and I need to write an expression for that. But before I do, I need to get my variables. I don't even have any variables in here yet. So what are we going to let X and Y represent? X and Y are going to represent the number of hours, or excuse me, not the number of hours, the number of lawns that I mow and the number of shrubs that I prune. So X and Y represent the number. X is the number of mowings, and Y is the number of prunings. Okay? So my income will be 40X and 120Y. That's my income. Because I get $40 for every X and $120 for every Y. All right, now I need to set up my constraints. And one of them is right here. That's pretty obvious. I only have 9 hours a day to work. An X takes 1 hour and a Y takes 3 hours. And I only have 9 hours to work. So I'm going to say X plus 3Y has to be less than or equal to 9. X plus 3Y has to be less than or equal to 9. Now, we got to come back because there's something in here that we got to make sure we make note of. Each crew is scheduled for no more than 2 pruning jobs per day. So pruning jobs are Y. What do we know about our Ys? Each crew is scheduled for no more than 2 pruning jobs per day. I don't know if you can read this or not, but each crew is scheduled for no more than 2 pruning jobs a day. So that means the number of pruning jobs that I do has to be less than or equal to 2, but it also has to be greater than or equal to 0. Would you agree with that? And X has to be greater than or equal to 0. But I don't think, I'm going to read it again to make sure, but I don't think there's any limitation on X. Each crew schedule, that's 90. Nope, I'm good. Everything in there is set. Okay, so now we're going to start graphing. So again, you can use whatever scale you want. I think this time our numbers are small enough. I think it's all going to be okay just to use a regular grid. But you can change it if you want. Doesn't matter. Get my graph set up here. And then we're going to start graphing these guys. Okay. I'm going to do that top one in red. So it's got an X and a Y, so that means you have to do one letter at a time. So I'm going to cover up X. And if I cover up X, Y is 3. So I covered up X. And Y is 1, 2, 3. So there's the point 0, 3. Okay. And then if I cover up Y, X is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to connect those with a nice line. Boy, if you have a straight edge, use a straight edge. And then that's less than, so we're going to color underneath. So we're looking at that triangle right now. This is the triangle we're looking at. Okay? Now, I'm going to do this one in purple. So, here's where Y is 0. My black line running across here, your x-axis, that's where Y is 0. Here's where Y is 2. And remember what we do. We draw a line straight across, right? And then we are looking in between those two, but in the triangle. So I'm in between my 2 horizontal lines, that bar right there, but I also have to be underneath the triangle. So I'm looking at that section right there that I have shaded. And that's it. So I've got a point here, and a point here, and a point here, and a point in here somewhere. So there are my 4 points. Now some of those are easy. For example, this is the origin. So 0, 0 is in there. Okay? This one is easy. Remember when I graphed this line, I plotted that point, that's 0, 2. This one is easy because I plotted that one too, that's 9, 0. This one is the tough one. All right, now look, what do we know about that line? That purple line across there is the line where y is 2. So that point has a y that's 2. What's its x? Well, I'm not sure, but it's on the red line. It's on the red line. And on the red line, if y is 2, then x plus 6 equals 9. Y is 2, so x would have to be 3. So that's the point 3, 2. Because y has to be 2. And on the red line, which is this equation, if y is 2, then this makes 6, and x has to be 3. So that's why that is the point 3, 2. So now I've got my 4 points. This one only has 4 points. And I'm going to figure out which one is the winner. So I have 0, 0, 0, 2, 9, 0, and 3, 2. Those are my points. Okay? So what do we do to figure out the answer to the question? We're on our very last step now. What do we do to figure out the answer to the question? We take those 4 points and we plug them into our income thing down here, income expression. All right? So obviously if you put in 0, 0, you get 0. All right? So we don't make any money if we don't mow or prune. All right? What if we mow 9, X is mow. What if we mow 9 lawns and no prunes? That would give us 9 times 40, $360. So if we did that one, we'd make $360. What if we did no mowing, but we did 2 pruning? Well, then we'd make $240. Well, what if we did 3 mows and 2 prunes? Well, 40 times 3 and 2 times 120, you'd make $360. Oh, this has never happened before. This is kind of cool. So you're the guy running this company, and you have to decide how many mowings and prunings to do. What happened? You got a choice, don't you? Because mowing 9 yards is going to give you the same income as mowing 3 and pruning 2. So our answer isn't going to be definitive this time. Our answer is going to be he can either mow 9 yards or mow 3 and prune 2 to earn $360. Now, in the real world, you'd have to decide, and maybe you'd figure it out by determining what takes longer. I mean, can you mow 9 lawns faster than you can mow 3 and prune 2? I don't know. That would be up to you to decide if you were the businessman. You remember I told you a couple days ago when we first started all this that every problem is going to look a little bit different, that little random things are going to come up. And this is certainly a different thing that happened here where we did not get a definitive answer. We got a possibility of 2 answers. Okay, well, that's it for now. Hope you're doing well. Bye.